Hello learners and welcome to this class. Today we are going to continue from our previous class on chemical nomenclature, and today we are going to discuss on chemical formulas. But we need to do a recap of our previous classes. In our previous classes we talked about atoms as the basic units of elements. That is, it is the smallest non-divisible part of an element. We also talked about elements as pure substances of only one kind of an atom. We also talked about elements being represented by one or two letters called symbols on the periodic table. Please recall on our previous class on nomenclature. We also talked about molecules. Molecules are terms used to refer to two or more atoms that are bonded. And an example include they could be monoatomic, for example, the case of oxygen where there are two atoms that are alike. And for example, they could also be diatomic, made of two atoms, like in the case of carbon dioxide where we have carbon and oxygen. When you look at the case of carbon dioxide, it is unique because carbon dioxide is both a molecule and a compound. By molecule is that it is formed of both carbon and oxygen, and by compound is that it is made of two different substances that are chemically combined with what we refer to as the other time as a covalent bond. Then what is a chemical bond that binds several elements or atoms to become compounds? It could be an electric force that joins atoms together. Remember when we learned about ionic and covalent bonds. The properties of a compound, however, are totally different from what it makes up. For instance, look at the case of carbon. Carbon is used during combustion, while oxygen is used for breathing in. The two combine to form what we call as carbon dioxide, and carbon dioxide happens to be what we breathe out. Look at another example of the case of an ionic bond of sodium and chloride. Chlorine is a very stinky, it smells, it is a gas with a very bad smell. Then when you look at the case of sodium, it is a silvery metal. When the two combine in an ionic bond, they form what we call as crystals or salts. Remember from our previous class we have discussed. And this is the table salt we consume when we are eating food. You can imagine that there are two different elements, a metal and a very noxious gas, that form a very good substance that is useful for our bodies. But now let us look at what we are supposed to look at today about chemical formulas. Chemical formulas are used to show the ratios of elements in a compound. For instance, look at the case of water here. Water is made of two hydrogen atoms and one oxygen atom. Meaning from the chemical formula you can see the ratio of hydrogen to oxygen is 2:1. Look at the case of aluminium oxide. Aluminium oxide has got two atoms and oxygen has got three. Please, you can calculate the ratio from here. Look at the case of ethane. Is that it has got two carbon atoms and hydrogen. Therefore, the ratio is 1:3. That is what we refer to as the chemical formula. It represents the ratio in which elements are bonded together to form a compound. The elements present in the compound are identified using different symbols, the symbols we talked about last week in our class on nomenclature. However, if more than one atom of the element is in a compound, it is shown using a subscript. Look at the case of oxygen, and other examples include nitrogen gas, carbon dioxide, hydrogen gas, and you can look for other examples from the periodic table. For example, water has got two atoms of hydrogen. Since oxygen has no superscript, there is no way you can write that it has got one cannot be a subscript. Hence, water is written as H2O. Sometimes some substances contain more than one molecule of an individual compound. And in this case, we do not use a superscript or a subscript. Instead, we use a coefficient. This is an example of a coefficient. And this represents 4 hydrogen atoms. 4 hydrogen, it does not represent 4 hydrogen atoms. It represents 8 hydrogen atoms and 4 hydrogen molecules. I think I should repeat that. When there is a compound that has got more than one molecules of the same kind, we use a coefficient. For example, if hydrogen gas has got more than one molecule, like in this case 4, we use a coefficient at the beginning. The coefficient is usually before the formula of the compound. Like in this case, this represents 8 hydrogen atoms and 4 hydrogen molecules. Another example, let us look at this case. This is sulfur trioxide. However, there's a coefficient in front here. The coefficient is 2, meaning there are 2 molecules of sulfur dioxide. When you look at it in total per atom, is that there are 2 sulfur atoms and 6 oxygen atoms. The total is 8. I have given a table here with examples. Look at the case of zinc carbonate. Zinc carbonate has got 5 atoms. It has got 1 zinc atom, 1 carbon atom, and 3 oxygen atoms. Let us look at another case that has a coefficient. This is sodium, 3 molecules of sodium sulfate. Sodium sulfate has got 18 atoms. It has got 6 sodium atoms, 3 sulfur atoms, 9 oxygen atoms, and the total sum is 18. Look at where the coefficient is and look at the subscripts that represent various compounds that have been bonded. Look at the case of what we commonly know as glucose. Glucose has got 24 atoms, 6 hydrogen atoms, 12 hydrogen atoms, and 6 oxygen atoms in a ratio of 1:2:1. Remember, we said chemical formulas, apart from representing the subscripts and coefficients, they also represent the ratio of a given compound, in this case glucose. Look at this example of 2 molecules of hydrochloric acid. There are 2 hydrogen atoms and 2 chlorine atoms. Total is 4. Look at all these compounds. They also show you the number of molecules. By the number of molecules is that if it does not have a coefficient, the molecule is 1. For example, the case of water, zinc carbonate, aluminium oxide. But when you look at the case of hydrochloric acid and the case of sodium sulfate, they have a coefficient, meaning these are 3 molecules and these are 2 molecules. Please, I have attached in the notes that I have attached in the module. I have attached a whole bunch of questions on our last week's topic on nomenclature and this week's topic on chemical formulas. Please practice on them so that you can understand even further. Good day.